All right, so we're continuing with Unit 5 today, and we're going to be talking about irrigation. We talked a little bit about it when we talked about agriculture, and so we're going to continue that conversation. So let's go ahead and jump into our PowerPoint here, and that should be... Oh, adjust our frame here, always. Okay. All right, so still in Unit 5, talking about irrigation. So approximately 70% of all the fresh water that is used in the world, not just in the United States, but in the entire world, is used for irrigation. And we know that there's really not a lot of fresh water out there. Hopefully you remember that there's only about 2.5% of the water on Earth that is available to us as fresh water. And so almost 70% of that goes into irrigation or into agriculture. So 4 main forms. Well, before we jump into the forms, let's talk about why we use irrigation. So we use irrigation because it increases productivity. Approximately 16% of agricultural land is irrigated. Only 16%. Now think about that for a minute. Almost 70% of the world's water is used for irrigation, but only 16% of agricultural land is irrigated. And yet that same small 16% of agricultural land produces 40% of the world's food. And so it has a huge impact on our worldwide food supply. There are some downsides to irrigation. So what are they? Because obviously it's a big positive that it increases productivity. However, sometimes when we irrigate land, we get waterlogged soil. And when soil gets waterlogged, the roots of the plant can't get enough oxygen. You might not think about the fact that roots need oxygen, but when they're in water-filled soil, they can't pull in oxygen from those pores that normally exist in the soil. And so it actually causes the roots to rot in the ground. So this is a big problem when soil has a high clay content or when there's too much water too fast. So this can be improved by either using more efficient irrigation systems or by changing the soil composition in order to decrease the amount of clay. Another problem with irrigation is this idea of salinization. So you guys might recognize that root word of saline. Salinization means that the soil has become too salty. And that salt is usually left behind when we're talking about irrigation through the evaporation of that irrigation water. So if the water contains even a fairly small amount of salt, over time, as we irrigate that field over and over and over again, enough salt gets left behind that it actually becomes toxic for plant growth. We can also get salinization through saltwater intrusion, and that could be saltwater intrusion like flooding, coastal flooding, or it can be that if an aquifer is near a coast and that aquifer gets depleted, then that can actually allow salt water to enter the aquifer. And then what we think is fresh water coming from the ground is actually salt water, and that can cause salinization of the soil as well. And salt is toxic for plant growth. So eventually that will make it so that the soil is no longer arable, can no longer grow plants. Okay, let's talk about our 4 forms of irrigation. So the first and the cheapest is what we call furrow irrigation. So basically with furrow irrigation, you build trenches, you fill those trenches with water. Unfortunately, this has a really low efficiency. And so each of these forms of irrigation, we're going to talk about efficiency. And what we're talking about is the percent of water that actually reaches the plant roots and is not lost either to evaporation or to runoff. And furrow irrigation is only about 65% efficient. That means that 35% of the water that we're using is lost either to runoff or to evaporation. And that water, as we know, is a very precious resource. And so it's not such great efficiency to be losing 35% of it. On the other hand, furrow irrigation doesn't require a lot of effort. It's cheap. Once it's done, you can use it over and over again. However, because you're adding so much water, it does tend to increase both waterlogging and salinization. Very similar to furrow irrigation is flood irrigation. With flood irrigation, rather than digging individual furrows, you tend to have a berm around a field. You flood it with water and let that water soak in evenly. This is more efficient, between 70 and 80% efficient. It's cheap, but again, it can lead to waterlogging and salinization. Okay, third form, and this is the form we most commonly see in the United States, is spray irrigation. And so this can be a center pivot type of spray. This can be typical sprinklers like you're used to seeing on our yards or as we see in this picture. Either way, with spray irrigation, water is pumped through a series of pipes or hoses to nozzles. Those are sprinklers. And this one is significantly more efficient, depending on the form, is 75 to 95% efficient. So much higher efficiency, but that higher efficiency comes at a cost. It does use more money, and it also uses more energy. And then our final form of irrigation is what we call drip irrigation. This is the most efficient form of irrigation. It is usually hoses or pipes with very small holes through which water drips very, very slowly. You will see this buried under the surface of the soil or sitting on the top of the soil. It has the highest efficiency of our forms of irrigation. It's 95% or better efficient. It also reduces weed growth because the surface of the soil tends to stay dry. Most of this water goes straight to those roots, and so it tends to reduce weed growth. It is, however, the most expensive form of drip irrigation in general. And if you are planning on plowing fields, it has to be removed before you can plow the field. So it can be labor intensive as well. So 4 forms. We have furrow irrigation, that's the least efficient at 65%. Flood irrigation, that is slightly more efficient at 70 to 90%. Spray irrigation, that is quite efficient at 75 to 95%. And then we have drip irrigation at 95+% efficient. So where's the water come from when we talk about irrigation? There's usually 2 primary sources, and that would be surface water. So that would be ponds. When you guys watched The Biggest Little Farm, they talked about having an irrigation pond. So the idea behind an irrigation pond and most farm ponds is that they collect rainwater and then you can use that for irrigation. Most farms also rely on groundwater. So that would mean tapping into an aquifer. And we remember that an aquifer is a chamber of rock in which water is trapped. So what's the problem with getting it from an aquifer? Well, aquifers are limited resources. So aquifers contain water that's been there for a really long time. Because it is trapped water, they recharge slowly. So even when we have a lot of rain, most of the rain is not able to penetrate into an aquifer. One of the most famous aquifers and one of the most productive aquifers is this one called the Ogallala Aquifer. It underlies 7 different states in the American Midwest. All of this is very heavy crop growing areas as well as heavy cattle growing areas. And so this Ogallala Aquifer has been being used for many, many years as a source of water for irrigation. And you can see in the image on the right that the change in water level is very, very significant. And so the Ogallala Aquifer is in danger of being used up, of being completely depleted. And even where it's not completely depleted, farmers are having to, and people are having to dig deeper and deeper wells just in order to reach the same water that they were able to reach in the past. Okay, so that's it for irrigation. We'll talk about it in class tomorrow. Do be prepared for a bell ringer. Have a great afternoon. If you have questions, let me know.